The CSAP portals collectively provide management and operational capabilities. Integration is achieved through a combination of back-end APIs aggregating information, as well as direct integration through the web browser. The application portal is generally the entry point into the management space, with cross-launches to other applications, analytics dashboards, and host dashboards. Other applications sharing the CSAP analytics service may be cross-launched by selecting the application and its respective environment. By default, applications will only show their respective environments. Here, I can cross-launch to another instance of the same application. Also by default, note that each environment has a unique theme to aid teams in differentiating the respective capabilities. The dev environment has a blue theme, multi-tenant environment has an aqua theme. Many settings, including themes, can be set via the Settings tab. In this instance, the theme is set to auto, which will select based on environment names, but this can be overridden by modifying the selection. Application landing pages include quick launchers and meters. Meters can be selected to view additional data. The application service launchers are a convenient location for teams to access their most often used services. The CSAP monitoring package includes the Kube Prometheus Grafana package for deep insight into Kubernetes performance. Shown here is the daily load test. The first item in the application launcher is always the launch to the CSAP Analytics portal. By default, the Analytics portal will open with the environment selected. By selecting all environments, teams can quickly see a comparison of resource utilization across all their defined environments. The Analytics portal provides extensive introspection capabilities. For example, the current 24-hour resource consumption pattern can quickly be compared to a previous week, and the UI will highlight the deltas. Similarly, if we want to simply look at the load levels and then compare those to a previous week. While there are several ways to access the host portals, one convenient methodology is to select on host and then select the desired host you wish to view. The UI layout is similar to the application portal with the following key differences. The addition of the Agent Dashboard tab and all other tab functions are limited to a single host. Some other items worth noting. Dev 04 has both Kubernetes and Docker deployed. If we compare this with another host, such as Dev 01, we'll notice that Kubernetes is not deployed, but Docker is. The command runner enables script execution along with the ability to edit. The same script can be run on multiple hosts as well. Simply select the host, select the desired hosts, and select Run. The command runner is integrated throughout the agent portal, including the top++ view. For example, selecting the CSAP agent sockets and then launching the socket, the command runner, and it will load the socket template. We can then run the script, and now we can view the process context along with its open sockets. By default, the top++ view will only show the services on the host, but it can also be filtered to show all OS processes. And in this instance, I'm filtering every OS process with the word Java. Another example of cross-launching is if we look at the file system view, which by default is filtering out all of the Kubernetes temporary mount points. We can actually select a mount point, which will then open up in the file manager view, and we can explore. Any view on the UI can be refreshed simply by hitting the refresh button, at which point we are back to what the default view would have been. We can open up, for example, the application definition and look at the application definition itself for this current project. Other key views, of course, include OS performance, so that we can look at it in real time, or we could look at it over the last day. And again, we will be looking at the load test run every morning. If process metrics are selected, by default, the top 5 CSAP services with the highest amount of CPU will be displayed. These, of course, can be filtered very quickly, and then only the selected service will be displayed. We can also view Java metrics, which in this instance is again showing the top 5 services. And we can also select the individual service we wish to look at. For example, if we select the CSAP agent, it will only show those views appropriate with respect to the CSAP agent. And we could, for example, look at the Java heap and look at the garbage collection over the last couple of hours. The view is customizable, so we could simply look at the last 30 minutes, and we can scroll backwards and forwards over that time looking at the heap collection. It is worth noting that many of the perspectives provided by the analytics and host views are also available as summary views in the application portal. For example, if we look underneath trends and select host resources, we can see that we can view trends over the past couple of weeks. We can customize per host. And we can also fine-tune it down to as short as the last 24 hours. The Events Browser provides insight into the CSAP event service. It includes all host performance data and user activity in the application environment. Events are categorized for quick selection. So for example, if we want to see all of the agent startup times, we can filter and view. We can also see the upload of the host performance data by selecting CSA Reports Host Daily. We can then select one of the reports and actually view all the data that's being uploaded. The project view enables teams to define their application services and then assign them to clusters. For example, if we filter by CSAP test, we'll see that we have a Kubernetes CSAP test cluster with 4 services assigned to it. These services can individually be edited with their attributes updated. Here, for example, we can specify which YAML files to use. And it's worth noting that in this case, host assignment is not done because an explicit Kubernetes provider has been assigned. Compare this with the base OS cluster. In this instance, these are simple services that need to be assigned explicitly to hosts. Service attributes and cluster definitions may also be edited via the project view once teams are familiar with the specification attributes. For example, you can open up the service templates and then select any of the services. So we'll go ahead and open up Elasticsearch. And now you can see a pretty readable and understandable configuration. Another helpful view is the attribute view. This is a quick way to edit service attributes. For example, showing here we're seeing all of the services listed along with the description field of each service. We could customize this by selecting the start order. Now we're seeing those services along with the order of startup. The environment view also enables teams to quickly modify their core attributes for a given environment. For example, here with the development environment selected, we can click on Settings. This will then load all of the configuration maps that are associated with that particular lifecycle. For convenience, you can also define a special environment called defaults. Defaults will set the default value across all environments. The host views provide access to real-time data feeds of key performance indicators. This includes the Kubernetes perspective, CPU utilization numbers, file system data, infrastructure tests, network, services, and OS. The deployment tab is composed of two aspects. The CSAP services deployment, which enables the view, add, update, delete of the CSAP services. And the second aspect is the Kubernetes deployment summaries, which allow you to view and inspect Kubernetes assets. For example, if we select the nodes, we can see that we have 3 Kubernetes nodes deployed with 1 master and 2 workers. We see that there's 7 volumes. We can click on any of these volumes and look at any of the inspect output. The pod viewer actually provides a summary by namespace. So we could go into CSAP test, and then we can pick any of the individual jobs shown here. And finally, the Kubernetes events, which are shown here. So to highlight this further, let's go ahead and remove the CSAP reference service using the CSAP deployment UI. To do this, we go to the services, we select the cluster, we select the service we wish to remove, and then we go ahead and remove it. By default, the process is shown on the UI once the remove is requested. CSAP includes the ability to have orchestration queries. In this instance, we're just waiting for all of the instances to be shut down. After about 30 seconds, all of the instances have been removed. If we come back and hit refresh on the service UI, you'll see that we are no longer finding any instances. And now when we look at the cluster, you can see that there are 6 stopped instances of the service. The distinction is that if we go back over to the pod view, you'll note that in the Kubernetes perspective, the service simply is not there. That is a key concept. The summary view is simply reporting on what it finds, not on what the intent of the application team is. To view intent, that is where we would use the CSAP view, which will clearly show that the service is in a stopped state and not available. To go ahead and deploy it, we can select the instance and then hit deploy. We can actually do customizations of the deployment schema. This is an advantage of using the CSAP spec generation. We'll go ahead and leave it as is and hit deploy. And once again, it's generating the spec, and then it's going to wait for the pod to actually be deployed. While that's deploying, just to highlight where that's coming from, we have actually included in the definition a couple of jobs to wait for the startup and wait for the shutdown. Now that it's completed, notice that we have the events have incremented, and if we go back to that pod view, we can now see once again that the reference instance is available. The key difference between these two views is that when we're using the pod perspective, we can actually do kubectl inspect, find out, when a service is up. In this instance, you were getting a probe failure, mostly because the JVM probably hasn't completed bootstrapping yet. From here, we could look at logs as well. In this instance, these are JSON logs, and this isn't so pretty to look at using a raw pod viewer. Instead, we could look at the logs through the CSAP viewer, and note that one of the advantages is that we can actually switch between the different pod instances very quickly. So we can go, in this instance, there's 5 different pods deployed, and we're flipping in between them. The reason the formatting is happening is because CSAP comes equipped with some smart parsers so that if it detects a JSON file, it will attempt to do some standard formatting of it. This can always be disabled, at which point you're looking at the same output that we were looking at underneath the pod view. Another related view to the Kubernetes summary view is underneath performance, Kubernetes Rt. This is essentially a real-time feed from the metric server and can enable teams to quickly identify any problem instances. For example, if I want to filter the view by just the Calico nodes, I can select the filter button and the view will be updated. We can then open this particular node up in the pod view. And once we're looking at the pod instances, we can click any instance to view the pod details. The pod details view contains the output of the kubectl describe command. If we hit fold and then browse down to conditions, we can see a summary of the pod state. You can also switch to the log view and then select whichever pod instance you're interested in viewing. If the pod contains multiple containers, you can also switch between those. Finally, we can, on the Details tab, select the definition view. The definition view shows the actual YAML specification used to deploy the spec. Note that this perspective only provides a read-only view. If we're interested in actually modifying the specification to try out some modifications, we need to open up the CSAP agent portal. In the agent portal, we can open up the pods to view all pods on the system. We can filter these down a little bit so that we can narrow the perspective. And then if we want to actually modify a deployed spec, we will need to find the corresponding deployment artifact. In this instance, the test K8s by spec is managed by its parent deployment, shown here. If we click on the edit option and then just browse down to an item that you would like to change, in this instance we will trial increasing the replica count. We'll go ahead, make the change, and click on update. We get a message saying that the deployment has been deployed, and we see the specification being deployed by Kubernetes. After about 30 seconds, we now see that the updated spec has been deployed. And if we use the filter, we now see that the 3 new pods have been created along with their associated cron jobs. The Kubernetes view on the application portal provides access to the performance data collected by the Kubernetes metrics service. When we're looking at the namespace, you see the namespace with the core allocation. We can select a namespace to view the pods, and then select the pods to get a summary sorted by either cores or memory of the data collected by the metrics service. The CSAP service view provides data collected directly from the OS. Switching over to the services view, we will select the CSAP service cluster, and then that same service, the CSAP reference service. The key distinction between the Kubernetes view and the CSAP service view is that in addition to cores and memory, connections, threads, views, and disk information is also displayed. Selecting the metrics view then gives 24-hour analytic views of the same data. This data is posted to the CSAP event service every 30 seconds. We can actually select the items to view the graph. And as shown here, we're viewing the performance test from this morning's test run. The other categories similarly can be browsed. In addition to the OS data, we can actually view application data. So for example, if we want to look at the landing page hits, or look at the number of active MQ messages. In addition to the service-specific collection, we can look at the generic Java collection, such as the Tomcat connections or the HTTP requests. It is worth noting that this view is providing data collected and uploaded to the CSAP Analytics service. If you wish to view data collected in real time, you can close this view and then just hover on any of the fields in the most recent collection. Now we're looking at a real-time collection feed of the reference service as displayed on the agent portal. It's worth noting that the agent portal, you can minimize to view all of the respective OS collection fields. And if we want to see the same analytic feeds over an extended time period, simply select the time period and then potentially zoom in on interesting data points. We can also switch over to the Java perspective. Zoom in on an interesting time period, as well as selecting a custom view to enhance readability. In this instance, we'll select the Java heap view. And again, we can zoom in on the interesting time period. The application perspective will provide access to custom metrics defined for the CSAP service instance. So for example, if we want to look at the JMS messages per second during the load test, again, it is critical to note when running any commands on the host portal, only those pod instances deployed on that host are being displayed. To view data across multiple instances, we want to launch the analytics portal. To do that, we'll return to the application portal ensure that we have selected all instances of the pods, select metrics, and then we'll click on the 24-hour average of a given field. Now we're seeing the pod instance on 4, 5, and 6. Note it's only showing one pod instance. To view multiple pod instances, we'll go ahead, customize the graph selection, and include the other pod instances. And then ensure that we have all host, all series selected.